Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 9.1, Problem 9. This is Section 9.1, Problem number 9. It says, how big a sample is needed for a 99% confidence interval if the margin of error is 6 and the population standard deviation is known to be 24? So, the formula for determining the sample size is n equals sigma times z sub c over e in parentheses raised to the second power. So, let's fill in the parts of the formula. And the size of the sample equals sigma, the population standard deviation, so that's given in the problem to be 24, times z sub c, the confidence coefficient. So we want the confidence coefficient for 99% confidence. So there's a little chart in our notes, and it says for 99% level of confidence, the confidence coefficient is 2.58. And then in the denominator, e for error or margin of error, the question asks us to use a value of 6. So let's not forget to put that in parentheses and raise it to the second power. So that's how the formula fills in. So now you can do the multiply and divide in a few different orders. If you notice, the 24 and the 6 do reduce, so you can just go 4 times 2.58. So if you double it once, 5.16, double it again, 10.32. I can actually come to the answer pretty quickly. But if you don't notice that, what a lot of people will do is just multiply across the top, 24 times 2.58, which they'd use their calculator to do, and it comes out to 61.92. You still have the 6 in the denominator. You still have the parentheses in the second power. Now your calculator will be out. This will be on the screen. While it's on the screen, you can just press divide by 6 equals, and you'll get that 10.32, which I knew was coming from my trick of reducing beforehand. So either way, the work in the parentheses will come down to 10.32. But don't forget, that's not the answer. It's still in parentheses. It's still raised to the second power. So for the final answer, what we have to do is 10.32 second power. In other words, 10.32 times 10.32. And when you multiply that out, the answer you get is 106.5024. Now, the rule for determining the sample size says if you have a decimal, round it up to the next biggest whole number. Now, even without that special rule, you still round this up anyway because the first digit out is a 5, and that's big enough to make it a 107. But in general, it's good to know for this particular formula of determining the sample size, even if it was a 106.2, you still round it up to 107. So if you have a sample of at least 107, you would have that margin of error of 6 and be able to maintain that 99% level of confidence.